this sort of resource sharing over time, this fine-grained resource sharing. So in this one, we have three applications. We have Spark, which is this new iterative MapReduce. We have Hadoop, and we have MPI. And basically, they each get submitted at different times. And we see a couple of interesting things. So first of all, we see when Spark is running by itself, it gets the whole cluster. It's running tasks everywhere, so you don't have this underutilization problem. When you submit Hadoop very quickly, the cluster becomes split half and half. And the reason it can happen so quickly, it takes, I think, about 5 or 10 seconds, is because we're doing sharing at the level of tasks. So as tasks from Spark finish, we can launch Hadoop tasks, and everything happens pretty fast. And similar thing happens when you launch MPI. And then these sort of dips at the bottom are because the Spark job itself is iterative and doesn't actually use all the nodes all the time. It has these waves where it scales up for a while, it does some stuff, then it scales down, crunches those results, and then it launches a new wave of tasks. And here we can see that the gaps between those can get filled in by Hadoop tasks. So that's the dynamic sharing graph. The graphs at the bottom are really just showing that, yeah, you can get data locality on Mesos, and you can get scalability. So on the left, I think basically we're comparing, we have a blue line, which is data locality, a red line, which is time it takes to run a job. And we're going from static partitioning of a cluster on the far left to basically Mesos on the right. And this was where we had, I think, 100 node cluster, and we ran 16 instances of Hadoop on it. And really all we're trying to show here is with static partitioning, your data locality is very low, 20%, and so your jobs take a long time to finish. And as you use Mesos and as you use this thing, delay scheduling, which is essentially how smart the job is about waiting for an appropriate node for itself, you get nearly 100% locality, and your job runs sort of 2 times faster. So that's that one. And then on the right, this is his scalability graph. This is actually from a stress test we did where we launched up to 50,000 nodes on Amazon EC2 using and had them connect to Mesos. We actually launched, I think, 200 physical nodes, but we had 50,000 slaves running on them. And then we measured, and we ran, I think, 200 frameworks with 30-second tasks. And we measured the overhead of starting a task in this highly loaded environment. And really, the takeaway here is that even with 50,000 nodes, the overhead is less than 1 second. So, so it actually does scale to a reasonable level. Okay, so yeah, so that's that. Any questions so far? What we're going to do next is we have a short demo of Mesos of the fault tolerance to show you. And then if there's some time, I'll talk a little bit about Spark as well, the new framework, which is also open source.
Question?
Yeah. Okay.
Did you explain how Hadoop actually, the port actually works?
Yeah, so, yeah.
Question?
Well, okay. Yeah, who wants to start? Yeah.
Upload scheduling models where jobs basically control place.
Yeah.
You also showed tasks sort of contributing to Mesos controllers or within. Can you elaborate on that?
Oh, on the two-level scheduling model. Yeah. So actually, this is it's a great question. I think, so I don't know how much time we have to talk about it. I can definitely talk about it online, but in a nutshell, the way we're doing it, we do this thing called resource offerings, where Mesos tells you, hey, here are some resources that are free in the system, some nodes or a slice of a node, and you choose the ones that you want to launch tasks on. So this is kind of backwards from the way people usually do scheduling, where the job gives some requirements to the scheduler, and then the scheduler does some crunching and tries to figure out good nodes. But this is sort of the research part of the system. We found that this actually works pretty well when you have these fine-grained tasks as you do in Hadoop, and when you care about data locality. So I don't know, hopefully that answered some of the question, but I can definitely talk offline about that. Yeah. Yeah. So.
Are the Mesos slaves running their own file system, or are you using?
Oh, we use HDFS.
How do you deal with versioning there?
We actually don't do that yet. So, at one point, HDFS will become backwards compatible in the API, and then it should be okay. But right now, it isn't. Yeah.
I have a question.
Yeah, let's just do this one and then do the demo because we can have more questions at the end.
Yeah. How does it compare with Condor, Matchmaker?
All right. Yeah.
Yeah.
That's
HDFS away.
That's a great question. It's also more of a researchy question. So I think our answer there is twofold. So it really goes down to this decentralized versus centralized scheduling. So with Condor matchmaking, because it's a centralized algorithm, it has some scalability limitations. So for example, with the 50,000 nodes, I think that would start to pose a problem for it. And it also means that if you can't express the requirements for your job in the Condor language, then it's not going to get the nodes it cares about. So with Mesos, what we're doing differently is we just tell the job about the resources, and it can pick whichever ones it wants without having to constrain itself to expressing these needs in some language. So yeah, but again, this is the more researchy part, and we can talk about it offline. It's a very interesting.
Condor scalability limit currently is because Condor is single-threaded.
Okay.
If it were multi-threaded, I'm sure. I mean, they are handling 4,000 nodes per thread.
Yeah, it's possible. Yeah, it's one of these things that. I mean, yeah, it's also more of an academic argument at some point because not many people have 10,000 nodes in clusters, but yeah. But this is something, it's a design we did in order to make the system very small and simple. And we're interested to see when it works and when it doesn't work that well. Yeah.
Porting Hadoop also to class sets, then Hadoop would have to express all these tasks, how to execute them and the locality constraints using class sets. It would be a much harder task.
I believe Condor has already made HDFS locality aware. That's what I've been reading from Meetup.
So we get this question a lot. We'd love to talk to you offline about more. Okay, so the demo I'm going to do is going to be pretty simple, but it has a lot of moving parts. So there's a good chance one thing will go wrong or another. What you see here is I have the Elastibox open for the EC2 cluster that I brought up using this Python script that basically it sets up a Zookeeper quorum for us. It sets up HDFS on the allocation in EC2, and then it pulls the most recent version of Mesos from GitHub and builds it. So this is what the Python script that I ran earlier today did for us. And it's basically running, as you can see, 4 nodes. One of those is a Zookeeper node, which you can see in the groups is Hug0 Zoo. And then 2 of them are masters, and we're only going to run 1 slave just for the demo to keep things as simple as possible, to minimize the number of potential things breaking. And then normally the script would run the Mesos master and slaves for you, but I killed them after the script ran so that I can do it for us manually. So now I'm going to see if I can get a window up, terminal. So I'm running screen, and I have and unfortunately I can't see very well. Let me mirror instead. This may be a risky operation. Alright, okay, cool. So now I'm mirroring. There. And I'm going to make this a little bit smaller. Maybe. Can people read that alright? Okay. So you see I have a bunch of screen tabs open at the bottom. Screen is a GNU tool that basically lets you run remotely. So I'm SSH'd into a node at Berkeley, which is SSH'd in turn into a bunch of these 4 EC2 machines. So here you can see kind of this first one labeled at the bottom, R2, is the node I'm SSH to go to Berkeley. Here's kind of the help command from where I ran the script. This is the zookeeper node running, and now here's the first master. So I have some of these tabs open in Firefox, showing, if I refresh, nothing's running. So I feel kind of like a magician. You can tell the blade is real. Now I'm going to run a pre-typed in command, which is the ben mesos master, telling it to listen on port 5050 for when slaves talk to it. And then I give it the URL of our zookeeper node so that it can coordinate via zookeeper with the slaves and the frameworks. And this will give us fault tolerance command. So I'm going to run that, and it says that it's now listening on port 8080. And if I switch back to Firefox and refresh this first tab, there's our web UI showing the Mesos master running. It has this unique Erlang-like globally unique ID, and it shows no frameworks and no slaves currently attached, and no active resource hoppers. So now I'm going to run a second master with the same command, so the same URL listening on the same port, the same zookeeper. It's also listening on 8080, so if I now shift to this next tab, we have two masters running. And now I'll run our single slave. So we're going to tell it to use the 4 CPUs that are in the EC2 machine. So this is a large instance, which means we have basically the whole machine, and use 4 gigabytes of RAM, and I give it the same URL for zookeeper. And so now it's listening on port 8081, and if I go back to our web UI, we're going to look at, it'll have picked one of the two masters, the one that's currently active, one that's not listed as a standby, and registered with it. So here, the master on the left, it did register with. If I refresh here, it's not showing up on this master. So there it is. Now, next tab, we're going to run 2 different Hadoop job trackers. So the first one, so I'm SSH on this tab into the master node, just to keep things simple so I didn't bring up another machine. So on the master, I'm going to launch, you can see the path I'm in here is Mesos Frameworks Hadoop 22. So if I run bin Hadoop job tracker, remember it set up HDFS for us, and fingers crossed. Okay, great. So now the framework's running. So what you see here is some output that in the second level scheduler, in the port of Hadoop, which is this job tracker that I just ran, we have added some output in logging that says when it gets a resource offer and what it does with it, basically. So it looks at the resource offer every time it gets one and decides whether or not it wants to accept that resource offer and run a task. Since there are no jobs running in this Hadoop job tracker, it doesn't accept any resources. So if I go back, hopefully, we see the framework exists in the master, the active master. Still nothing exists in the other one. And it's using, of the 4 CPUs and 4 gigs of memory that are available in this single slave that's registered, it's using none. And that's because none of the task trackers have been launched yet because no job has been registered. So you have this job tracker speaking to the Mesos and getting resource offers and rejecting them all because there are no jobs, so it doesn't need the resources yet. So I'm going to run another job tracker on the same node. So you can tell this one's now, we had to set up, change the ports because one was using 50030 and one was using, now the other one's using 6030. Doing the same thing, it's getting resource offers, and hopefully it shows up in the web UI. So now we have 2 frameworks registered. And now we're going to try the thing that's been most likely to break on me, is I catted Romeo and Juliet, the text file, against itself like a few thousand times, and it made it about 1 gigabyte worth of text. And now we can do, oh, that's not what I want. I want word count. We can do a word count on it. So it's called Romeo and Juliet Big, and I'm going to output it to something with a random string since I've done this a bunch of times. So now we have a 1 running MapReduce job. Let's see if one of these. So one of those has started running tasks now. It's accepted 1 task, it's probably setting up the job with that task. And now it's running 4 tasks, it's going full bore. Let's see if we can get the other Hadoop job running. So the same job, doing word count on the same thing. This is now, you'll notice up here we have Hadoop 2. So it's a different Hadoop that we're running inside of. So both of them are running. Maybe. So because the first one is still running its 4 tasks, the second one's going to wait until one of those tasks completes. Mesos is then going to use its allocation module, its allocation policy, to decide that the second framework that's registered is below its fair share and deserves some of these tasks. So let's check. These last 2 tabs should be the job trackers on the 2 respective Hadoops. So one of them is, they're on the same node, but one of them should have a running job that's making progress, and the other one doesn't have a running job yet. Uh-oh. Okay, so regardless of whether the tasks, okay, so this one's making progress. That's good. Okay, so there it goes, making progress. Let's see if it's still got all 4. Okay, good. Oh, wow, it's doing what it's supposed to. All right, and yeah, this is more than I've actually done so far in my practice runs. Okay, so here's the fun part: is we go to one